This video will look at the probe options within ColourSpace, which are within the main profiling window, probe options. And here we can select the probe that we want to work with that's supported by ColourSpace, and when selected we'll activate the associated options. The i1 D3, i1 Display Pro, it is a direct connect probe, which means you don't have to select a comms port for it. It's all automatically connected, as is the i1 Pro 2 and 3s. Also, you've got an auto button there. What that will do is reconnect to the probe whenever you start ColourSpace, assuming that the probe is physically connected to the ColourSpace PC. The next option that we have are the calibration settings, which are preset matrices for the connected probe, assuming it has them, and these are held within ColourSpace itself, and you can select the one that best matches the display technology that you are working with. We tend not to use these, as we tend to prefer using probe matching, because it gives a far more accurate result than using what are basically generic presets. Probe matching is something that there is a separate video for, and we'll come back to this a little bit later here as well. Below that we've got intelligent integration, and this will basically use the preset nits value to disable intelligent integration on the probes that support it. Presently it is just the i1 D3, and basically if a patch reads below the set nits value, it will immediately take a second reading with a longer integration time and compare that to the first reading. If the two readings are within a tolerance, it will accept that as being valid and move on. If there is a difference, it will take another patch reading with an even longer integration time and compare that to the previous one. And it will do that repeatedly until it hits the maximum integration time for the given probe. At that point, that last reading will be the one that it will accept as being the most valid it's going to get. Average low light is an alternative, and basically below a set threshold will take multiple readings of the same patch and average the values. There is no point in using both intelligent integration and average low light together. And enable visible feedback just disables feedback from the probe itself, the hardware. In the case of the i1 D3, it just turns on or off the LED light on the side that shows you the probe is connected to and communicating with ColourSpace, as well as when readings are being taken. With probes such as the Jetty and Klein, it will disable the inbuilt laser alignment pointers. If available, the probe calibration will perform either a black or white calibration on the probe itself. On the right hand side we have the probe integration time, which can be set to any given value either using the slider or numerically entering any direct value you choose to choose. Obviously, the longer the integration time, the slower the probe readings will be and the longer the profiling will take. Having a slower read time, so a longer integration time, potentially will give more stable, more accurate results, but at the expense of increased time. But also, if the probe starts to oversaturate, then you will actually get invalid readings. So it's a balance between having stable readings on a given display with the quickest integration time that works. For all of these settings, if you're not sure what they do, they are explained in the Light Illusion website. If we actually go to the website and go to ColourSpace Guides, and if we choose the i1 D3, you can see that it will jump to the specific tab for ColourSpace integration and explains the various menu options and settings. It will also show, in this instance, integration notes, which talk more about the sync modes, frequency, period, burst, all in one. So you can understand the benefits or not of the different options and how they work, especially in conjunction with intelligent integration. Maximum exposure times not used with the i1D3. Obviously the sync modes we've just seen within the Light Illusion website. Extra delay time is more of a global setting. By that I mean extra delay time is available regardless of the probe that you are using. And what this does is delay the point at which the probe starts taking a reading after the triplet value has been sent to the patch generator. For example, if you have a display that has a slow response time to the input video signal, you may need to have, quarter of a second, half a second, whatever, extra delay, because the patch takes that little bit longer to appear on the display screen being profiled compared to the patch actually popping up on the patch window within ColourSpace. Having said that, if you're using an external TPG, it's unlikely that that will require extra delay, because the triplet value is sent to the TPG before the patch changes within ColourSpace. So there should not be any extra delay time required when using external hardware test patch generators. The other use for extra delay time is if the display has colour memory. In other words, it takes a little while for a changing colour to settle. Some technologies like plasmas and OLED can suffer this. So you may want to add a little bit of extra delay time to allow the patch to settle before you start reading it. Again, the slider sets the value, or you can directly set any value you want using the numeric input. Probe offset is for adding things like JUD offset values. Nowadays not really used, because perceptual matching gives much better result, and is something that we would certainly tend to use in preference to just a simple probe offset. And then we've got the probe matching. Probe matching, we said we'll come back to, because it's one option that is actually available when the probes are not connected. Because with ColourSpace, probe matching is retrospective, which means you can profile a display, save the profile, and then apply probe matching to it after the event. So you don't have to have a probe connected to be able to use probe matching, so long as you have obviously added the correct probe measurement data into the probe matching window in advance. So let's connect to the i1D3. We'll pop up the patch window and we will start a new. So let's just take off none. Just as a safety precaution, you don't want to have anything in the reference probes when you're doing a new measurement, just to be safe. It should make no difference, but just in case. So we're going to start a new, and we'll just call this test i1D3. And we can use measure all, which will run through the 3 color patches and the white patch, red, green, blue, white, and take 3 readings of each and average the value to give you the Y, X, Y values for this display with this particular probe. And there we go. You can use the measure button to update just that one color. So here we're just going to update red. You can also manually enter values. So if you're using an external patch generator and probe with its own software, you can manually enter readings taken from elsewhere. And at the end of the day, all it means is you have data for the i1 Display Pro on the particular display that you are working on, which you can then match to a Spectro that has had the same measurements taken on the same display. And just delete that because we're not going to use it. If you're working with different probes, so let's go to CR100 for example, which is on COM8, connect to that. You can see that the options tend to change dependent on the probe, so they will be in a similar layout but of different options and capabilities.